Example 3, in a random sample, 36 of 72 men and 35 of 50 women indicated they would vote yes. Tested the 5% significance level. Is there a significant difference between the two proportions, male and female? Who will vote yes on proposition A? So step 1, you ask the 2 questions. Which situation are you in and which testing are you dealing with, right? So how we know that which testing we're dealing with is so the keyword here is difference. We're looking for two-tailed testings. We're looking for are they the same or are they not the same? Second question is which situation we're in. And how we know which situation we're in is because we're given 2 numbers for male, 2 numbers for female. So we know that we need to divide these 2 numbers to get a percentage. So once we know we're dividing these 2 numbers to get a percentage, then we know this is proportion. So proportion is basically your percentage. And we have 2 groups, so 2 samples, 2 sample proportions. So that's the first step. You ask 2 questions. Second step is you state your H0 and H1. And to get the H0 and H1, we look at the formula sheets, right? So we know that we're dealing with proportions, and we know we're dealing with two-tailed testings. So when we're looking at the H0 and H1, what we can see here is that H0 is pi1 minus pi2 equals to 0, and the H1 is that pi1 minus pi2 does not equal to 0. So this is what we put into the H0 and H1. And H1 is what we're trying to prove. We want to prove that pi1 proportion 1 does not equal to proportion 2. This is what we want to prove. So that's your second step. Third step is you calculate the statistics. You compare that statistics with the critical. And then in chapter 9, we know that for proportion, when we're dealing with proportion, we use Z distribution. So same idea here. We use Z statistics. We need to calculate Z statistics. And the formula I gave it to you here. So you can read that on your own. So P1 is your 36 divided by 72. That's your P1. Proportion 1. Proportion 2, sample proportion 2 is your 35 divided by 50. And then I give you the P bar here. And you substitute those values into the formula. And then what you need to know is that pi1 minus pi2, that is 0. The reason it's 0 is because our H0 is that pi1 minus pi2 equals to 0. So pi1 minus pi2 equals to 0. So we put that into here. The reason we can put it into here is because we have to assume that this is true because we haven't proved anything yet. We haven't proven anything yet. Since we haven't proven anything yet, we have to assume that H0 is true. So that's why we put pi1 minus pi2 equals to 0. That's why we put it in here. So once you have all these values, you substitute that into the formula, and then you're going to get negative 2.2. So that's your test statistics. Once we have Z statistics, then we can calculate Z critical. And we use the same formula in chapter 9. So in chapter 9, we know that when we're dealing with proportion, when we're dealing with percentage, we use the formula for critical value, norm.s.inv. So norm.s.inv, this is the formula that we use for proportion, for percentage. And we know that we're dealing with two-tailed testings. So for critical value, two-tailed testings, we use alpha over 2 and then 1 minus alpha over 2. That's the 2 probability that we put into the norm.s.inv. So that's why when we calculate the norm.s.inv formula to calculate the critical value, we use 0.025, we get the negative 1.96, and then we do it one more time, 0.975 for the norm.s.inv, 0.975, we get a positive 1.96. So we have 2 critical values because we have 2 tails. Then we compare again, 4th step, then we compare statistics with critical. We know that absolute value, statistics is greater than critical. So therefore, we can reject H0, we can accept H1, and then we can accept that the pi1 minus pi2 does not equal to 0.